Assalamualaikum warahmatullahi wabarakatuh. My name is Sashi Hazari bin Abu Bakar, and this is our group to do the lab report video of undamped beam oscillation of laboratory mechanic of machine. My name is Sashi Hazari bin Abu Bakar, and this is our group mates and our lecturer, Encik Wan Muhammad Wardi. Now we go to the introduction of the experiment. Many machines, particularly automobiles like cars, trucks, including large spinning component. Trucks and automobiles have crankshaft pistons that are spinning inside the engine. This spinning part could be problematic. Vibration will occur. Vibration will make more when the component rotates due to out of balance centrifugal force. It must be have any problems through the spinning object in the engines. This may be okay at modest rotational speeds, but at high speed, it may be harmful, problematic, or even destructive. Even relatively slow-moving vehicle tires must be carefully balanced to avoid hazardous vibration accidents in the highway or roads throughout the suspension system and uneven tire wear. Next is the objective of the experiment. One is to illustrate the difference between static and dynamic balancing and their types of advantage. To slow what if the shaft is dynamically in balance is it automatically in static balance, but the reverse is not necessarily true. And the last one is to evaluate a mathematically or graphically for a balanced shaft, and correctness of the finding can be done and evaluated. Next is the additional theory for balance in one plane. As you can see, the figure is showing of one plane rotational at the center of gravity. When the system is simply this, static balancing is all that is necessary. Considering a thin disk or wheel with a different center of rotation than its center of gravity, a simple approach to verify or for static balance is to place the wheel on frictionless bearing. If the center of gravity is in the distance of r from the center of rotation, centrifugal force will be produced when it spins at speed of revolution per minute. This is the out of balance force. To cancel it out, to reduce the vibrations, and an equal opposite force is required. Simply add mass to m2 at the radius of r to do this as shown. The two forces must be equally powerful to get the balance of the rotational. Next is the balancing in separated plane. Even if a static equilibrium exists, centrifugal force will cause a turning moment. You see the figure, the left side of the figure is the separated plane, but it's unbalanced. The force acting on the system's center of gravity add an equal and opposite force between two places to solve the problem, which is the figure at the right one. Is shown as in balanced condition. The diagram despite depicts the force acting on the center of gravity by adding force between two planes.
Greeting and salutation. I'm Shunan. Today I'm going to explain about equipment. So equipment that we use, we will have the power point which connected to the accelerator, which connected to the motor, and then the system have 4 plates, identical plates, and the system is connected via 2 identical springs. So next I will explain about the procedure. So the procedure is, first of all, we will review the lab sheet and we will find out the correct mesh which need to connect it to the plate A accordingly, and then we will check and turn on the power of the accelerator and motor, and then we start to accelerate the system. The plate will accelerate and we need to find out the system is in balance or not. by watching it perpendicularly and state the observation in the result table. So the procedure will repeat it to the multi-stages plate, which is A to D, and the mesh will be placed accordingly to the lab sheet. Next, I will explain about the result. So this is based on the observation. The result is based on the observation, and we need to compare with the theoretical. So the result that we obtained in this experiment is same as the theoretical result, which means the system is operating accordingly. Thank you.
Next is observation. This experiment is to prove basic balancing principle. The balancing rotating mass experiment is equipping the equipment with accelerator and rotating disc connect with piston. The apparatus related to two springs to the bar. When the system accelerates without any mass, the system oscillates in balance with vibration at the spring. When the mass of 30 gram was added to the disc D at 60 mm distance, the system had heavy vibration and is oscillate unevenly. Right. I'm Hassan and I will present for the discussion. First is explain the result obtained from the balancing of rotating masses for a single plane. Okay, from the result, the balancing of rotating masses experiment for a single plane shows the data obtained under the same experiment condition follows the theoretical hypothesis data and some are not. For experiment A, both data from theoretical and experiment are imbalanced, caused by only a sole mass being added to the plane. Next is explain the result obtained from the balancing of rotating masses for multiple planes. The requirement for balance condition is mass 1 times radius times distance must be equal to mass 2 times radius 2 times distance 2. One of the factors must be considered in this experiment is distance between the plane in order to achieve the balance condition. Is give an example on the application of balancing of rotation in real-time world and describe why balancing of rotating masses is important. Okay, the crankshaft is an internal combustion engine overseas translating the reciprocating motion of the piston into rotation motion. Shaft balancing reduces vibration, resulting in smoother engine performance and enhance overall vehicle comfort. Crankshaft balancing reduces stress and extend the lifespan of this component, resulting in increased reliability and lower maintenance costs. Engine may produce energy losses caused by imbalance, resulting in enhanced fuel efficiency and performance. The crankshaft is balanced to help lower noise level, resulting in a quieter engine and more comfortable during driving experience. That's all. Thank you.
We can conclude that the objective of the experiment were achieved, which were to illustrate the difference between static and dynamic balancing and their types of advantages, to evaluate a mathematically or graphically for a balanced shaft, and the correctness of the findings can then be evaluated by setting up and operating a motor-driven shaft, and to show that if a shaft is dynamically balanced, is automatically in static balance. But the reverse is not necessarily true. To recap, balancing is important to prevent vibrations, especially in large industrial devices like electric generators and steam turbines, which could result in catastrophic failure. Another example is when a wheel of an automobile is out of balance. It could cause a loud and painful vibrations, which will make the ride to be very rough. There are two types of balancing, which are static balancing and dynamic balancing. Static balancing happens when there is no resultant centrifugal force and the center of the gravity is at the axis of rotation. Meanwhile, dynamic balancing happens when there is no turning moment along the axis. There were two experiments conducted which were balancing of rotating masses for single plane and balancing of rotating masses for multiple planes. For single plane, it was found that some of the experimental condition followed the theoretical condition, while some does not. There are two causes which might lead to this finding, which were uneven distribution of mass around the axis of rotation and variations in assembly process, which led to uneven distribution of masses. For multiple planes, it was found that the experimental condition and theoretical condition were the same under the consideration of static and dynamic conditions. Experiment A of dynamic balancing was in imbalance condition due to resultant turning moment along the axis of the plane was not equal to 0. Meanwhile, for experiment B, C, and D, on the other hand, were both in balance condition for static and dynamic balancing. Overall, the experiment were a complete success. Thank you. That is all from us.